Hello, this is Aishwarya Gopi. Welcome to my presentation on Gradle Build tool. In this video, I'm going to talk about Gradle Build tool and how it helps with software development, since we all know software development is a complex process. I'm going to start my presentation with a real use case scenario to understand the topic better. Web application development consists of front and back-end development. I'm taking the example from course CS5244 offered by Dr. K and Dr. Atkinson. Front-end is the UI where I used Vue. Back-end, I used Java. For the above project, after coding the logic and designing the front end, I had to build the project and submit or post my project to server. To do that, I had to follow the process mentioned here. npm run build. I had to build a project. It creates artifacts in the dist folder, which resides in client folder of the project. Copy the artifacts from the dist folder and paste it to the web app folder present in the server folder. Then Gradle build. War file is created in the libs folder, which resides in the build folder. Copy the war file and post it to the server. To complete the following steps, it would take somewhere around 5 to 10 minutes. That is not a problem for a small project like this. But imagine the same process for large projects where several developers are working on a number of features and times that takes to complete it. Pause and think about the time spent by the developers on it. How much it would cost the company for performing this monotonous work. Let's take 5 seconds. Yes, the cost is definitely high. Developers must work on solving problems and creating new things. When considerable amount of time is spent on building a project, their productivity goes down and the cost for the company goes up. This is where Build tool comes to play. So what is a Build tool? Build tool is a program that helps to automate several manual tasks performed by the developer. It automates the process of compiling, testing, packaging, and deploying the source code into an executable form before it is handed over to the end user. History of Build tools. Let's just go through a quick history of Build tools. I will not go into details but just lay out the timeline of different Build tools. The first ever Build tool was Make, which was introduced in 1976. Next came was Ant in 2000. It was widely used among developers. It was fast and flexible. Apache Maven was introduced in 2002. This one was also widely used among developers, and it is based on configuration over convention philosophy. Then Ivy was introduced in 2004. Then Gradle 1.0 in 2012. Let's talk about Gradle and why. Gradle is one of automation build tool that is widely used among Java developers. And of course, it supports many languages. Gradle is widely used because it took over the pros of Ant and Maven. It uses convention over configuration philosophy. It performs parallel task execution and dependency management. Domain-specific language, DSL. There are two domain-specific languages in Gradle. One is Groovy, and another is Kotlin. Let's talk about Groovy. Groovy allows imperative programming. It is free, and it allows integration with Ant, Maven, and Ivy. Creating a Gradle project. Let's see how to initialize a Gradle project. Here, I'm going to do a sample Java application. Run Gradle init command in your terminal. When prompted, select number 2, application as your project type, and number 3, Java as implementation language. You can choose DSL for build scripts number 1 Groovy. And for all other questions, press enter to use the default options. The output will look like this. Simple Java project layout. This will be the layout of the project once the project is initialized. Settings file define build name and subprojects. Build.gradle contains the build script for the project. There is default Java source folder and default Java test source folder. It has also generated folders for wrapper files. In git ignore, you will specify the files which you do not want to track the version. Now you have the project set up to build a Java application. Project build file. Build.gradle file contains the following sections: plugins, repositories, dependencies, and application. Let's look at one by one. Gradle plugins. Add all the required plugins to support your application. You can add preferred IDE and programming language as your plugins. Apply the application plugin to add support for building CLI application in Java. Gradle repositories. Declare the repositories you need for your project. Repositories will host all the dependencies. Some commonly used repositories are JCenter and Maven Central. Gradle dependencies. Implementation. This dependency is used by the application. It will be delivered to the customer and end user. Test implementation. Use JUnit test framework. It's only for testing purpose. Gradle application. Here, you have to define the main class for the application. Gradle will generate application package like zip or tar with all the dependencies and executables for launching your project. Some key takeaway from my presentation. First, build tool enables automation of manual process. The manual process is not beneficial for the company since the developer's productivity will go down and hence the cost goes up. Developers' time must be invested on creating new things and solving problems. Second, to package the application, we need to ensure all the dependencies are available, compile the source files against the dependencies, and run test cases. The build tool helps to automate the process of downloading and managing the dependencies for you. It will ensure correct versions are used and avoid integration problems later in the project. In large projects, it gets tedious to track the order of execution. Here, Build tool takes care of it. Finally, it saves time by parallelizing tasks and continuous integration and deployment, which helps to find defects early as it is important for software development. That's the end of my presentation, and thank you for your time.